So here is our practice test for Unit 8, and you can skip 3, 4, and 6C. That's on Part 1, and then 3 and 6 on Part 2. Okay, so let's go ahead and get started. It says here, if the first term in an arithmetic sequence is 30, a sub 1 is 30, and the fourth term, a sub 4, is 45. Find the eighth term. All right, this is one of those where I'm going to go to my calculator and I'm going to go to Stat and Edit and enter my data. And since it's arithmetic, I'm going to choose linear regression to get my formula. Okay, so let's go to Stat and Edit. Got to clear out what's there. My first term and my fourth term, and I have them as 30 and 45. Now, because it's arithmetic, I'm now going to go to Stat and Calc and choose linear regression. So Stat and Calc, linear regression, and I get my formula. So it's going to be a sub n equals 5n plus 25. And because I'm looking for the eighth term, a sub 8 is 5 times 8 plus 25. And that's going to give me 65. If the first term in a geometric sequence is 45, so a sub 1 is 45, and the sixth term, a sub 6, is 10,935. What is the fourth term? Right, again, I'm going to go to Stat and then Edit. So let's do that, Stat and Edit, clear out what's there. First term and sixth term are 45 and 10,935. Now this time, because it's geometric, when I go to Stat and Calc, this time I'm going to choose Exponential Regression. I'll also write that here. So I'm going to go to Stat and Calc, Exponential Regression, and so I get g sub n equals 15 times 3 to the nth power. Okay. Because the 15 is the a, the 3 is the b, and I just used n rather than x. So g sub, what are we asked to find? What's the fourth term? G sub 4 is 15 times 3 to the fourth. So 15 times 3 to the fourth. And I get 1,215. Right, I get to skip that one. Let's go down to number 5. We're asked to write an explicit formula for this sequence. Whenever I have a fraction like this, I treat the top as one sequence, and I'm adding 1 to the previous term. And here, I'm adding 4 to the previous term. So my formula is obviously arithmetic. The numerator is going to be 1 plus 1 times n minus 1. And my denominator is 3 plus 4 times n minus 1. going to distribute and get 1 plus n minus 1 in the numerator. Distribute, and I get 3 plus 4n minus 4 in the denominator. These cancel in the numerator, and I'm just left with n. In the denominator, I would have negative 1 plus 4n. And there's my formula. Let's go to the next page, number 6. Let S of n be a sequence where the first term is 16 and the second term is 12. Write an explicit formula for an arithmetic sequence. This is just like the first problem. So S sub 1 is 16, that's the ordered pair 1, 16. S sub 2 is 12, 2, 12. I'm going to go to Stat and Edit. So 1 and 2, 16 and 12. And because it's arithmetic, that's going to be linear regression. So now I'm going to hit Stat and Calc and choose linear regression to write my formula. Right? So I've got Stat and Calc, linear regression. And instead of x, I just write n. And instead of y, I just write a sub n. So a sub n equals 4 times n plus 20. And there's my explicit formula. Letter B, write an explicit formula when it's a geometric sequence. So I'm going to still do Stat and Calc, but this time, since it's geometric, I'm going to choose exponential regression. It's the same term, so I don't have to change anything there. So, Stat, Calc, exponential regression, because it's geometric. Then I get G sub n is 21.3 repeating, which is 21 and a third. I guess I'll leave it like that. 21.3 repeating times 0.75 to the nth power. Okay. Alright, we are just moving quite along here. Let's go to this next part. What is the seventh term in the sequence defined below? Well, the first term is 8, and then we're adding 6.5 to the previous term. So I have a couple options here. What I can do is take 8 and add 6.5, and I get 14.5. Then I can add 6.5, and I get 21. And I can keep going till I get to the seventh term. So that's the third, fourth, fifth, sixth, seventh. And I get 47. So I could just have kept writing down these terms. Not that I'd have to write them down, I'm just doing that to show you the work. And I used my calculator. Or, if I want to, I can write an explicit formula. 8 plus 6.5. So this is a sub n because it's arithmetic, times n minus 1. If I'm looking for the seventh term, a sub 7 equals 8 plus 6.5 times 6, because 7 minus 1 is 6. Use my calculator. 8 plus 6.5 times 6, and I get 47. I still get 47. So I just wanted to show you two ways to do it. I could actually go through and find the 7 terms and get to the seventh one and get 47. Or I can write the explicit formula and find the seventh term. Next one, what is the sum of the first 300 integers? That's going to be a series because it's a sum. And because I'm adding up the integers, that would be 1, 2, 3, all the way up to 300. And I keep going up by 1. That means it's an arithmetic series. So I'm going to use my formula. S sub n equals n divided by 2. And I'm going to use that first formula because I know the first term and I know the last term. S sub 300, because I'm looking for the sum of the first 300. It's 300 divided by 2. My first integer is 1, and my last integer is 300. So S sub 300 is 150 times 301. Use my calculator. 150 times 301, 45,150. Let's go to number 4. Just 2 more and we're done. Look at the arithmetic sequence below. Sorry, off the screen here. They tell me it's arithmetic, so I know there's a constant difference. It must be having the same thing happen from term to term. And since I know it's a constant difference, remember the difference is always term minus previous term. And because I already know it's arithmetic, I can pick any term and subtract the previous. I could choose this term and subtract the previous, or this term and subtract the previous. I'm just going to go ahead and do negative 32.7 and subtract negative 20.2. Term minus previous. Term minus previous. I'm going to go to my calculator. Negative 32.7 minus negative 20.2. And I get negative 12.5. So recursively, the first term is negative 20.2, and you find the nth term by taking the previous term and subtracting 12.5. That is my recursive. My explicit would be a sub n is the first term, negative 20.2 minus 12.5 times n minus 1. Right, and my last problem, write the explicit formula that generates the same sequence as the recursive formula below. We had one like this on the drill. My first term is 20. It says take the previous term and subtract 0.6 of the previous term. I like to think of these as like terms, kind of like x minus 0.6x would give me 0.4x, because this is 1x minus 0.6 is 0.4. So S sub n is going to equal 0.4 times S sub n minus 1, which means you find the term by multiplying the previous term by 0.4. So my explicit formula, this is geometric, is the first term 20. The constant ratio is 0.4 to the n minus 1, since this is the first term. And that's my explicit formula.